Good morning, students. Good afternoon or good evening, wherever you're watching from. This is Mr. Yomi Omorewa, a mathematics teacher at Day Spring Christian College. Yesterday, I started a topic called indices, and I did explain from the word index and then the loss of indices, and we also did some practicals. In other words, we did some examples. There were some few questions that were left unsolved, and I did say that you should endeavor to solve them. And in case you're having any issue, you're free or you're at liberty to drop it in the comment section. I'll gladly attend to your question. I would like to continue from the last class I had, and today, so I'm looking at Indicial Equation. Indicial Equation actually is a continuation of what we've considered. If you understood what I taught yesterday, this is not going to be a challenge to you. What do I mean here? Now, the word exponent, because we'll still be talking about power, and so if you have understood what I did yesterday, you will not have an issue here. Only that in this case, you're not simplifying, you're not evaluating, but you're solving. You are solving to get a definite answer. Either you're looking for Y, or you're looking for X, or you're looking for any of the alphabets, because it has to do with solution or equation rather. Now, example is this. Let's say you are told to solve something like this, and here you have 16, and you are told to solve. Obviously, you know that this is not a question to struggle with, because the exponent, you can see what is happening here. This is base and this is power, and the base is 2, and you have it. And obviously what we have here is a factor of what we have at this point. So you can discretionally tell what you will land, where you will land at. What do I mean? Look at this now, we have this. This is automatically going to give you 4, because you know that 2 raised to power 4 does not mean 2 times 4. It means 2 multiplying itself in 4 places. And that will give you 16 right there. So we have to cancel the base, and then the A gives you 4. And so if you want to find out whether you are correct, you want to check, you take in the value of A, put in there, A raised to power 4, you get exactly 16. And that shows you are very correct. Look at this again. Number 2. You are told to solve something like this. Let's assume you are asked to solve something like this, and here you have 81. And the question is, you're looking for n. And now to solve n, of course, you know that this is 81. I want to ask myself, is there a way I can raise this power base to an exponent that will be equivalent to what I have here? So I begin to troubleshoot, I begin to rack my brain to check off. So what do? I have something like this. I know I can't raise this to the power of 2, but I can raise it to the power of 3. 3 raised to power what now? I know 3 times 3 times 3, so that's going to be 4. And so 3 raised to power 4 is the same thing as 81. And then I can easily cancel my base. Now, let me say this very quickly. Friends, it is not only the base you cancel. There are times the base will not be the same, and the power will be the same. You can cancel the power. It all depends on where you're going. But for all the one we have been solving now, so it is the base we are cancelling. So we have this. And what do we do now? I want to make n subject of formula. So I quickly take in here. So we call that collect like terms. So n therefore becomes 1 plus 4. So my n is 5. I'm sure that's pretty simple. So I will graduate from here now to something a little bit higher. Now look at something like this. Number 3. You are asked to solve, say, 9 raised to power 2 minus 1 over 27 plus 1 equals to 81 3x 2. Now you can tell that this is quite different from what I've been touching even before now. There are 2 ways I can tackle this. I wish I can show you. Method number 1. Method number 1, I'm saying something like this, and I know from the previous class we had I talked about division rule. In the division rule, so we have this. Now I can say 9 raised to power 2, 1, and then 27x plus 1, and then 81 3x 2. So what do I do here? I simply raise this to the power of 2, and then I have 2x1, and then I raise this to the power of 3. Obviously, it's still the power of 3 I'm using. And then I can raise this to the power of 4, and then I'll have something like this. I'm sure that's very clear, right? Okay, so what's the next thing? I'll do this. Open the bracket. So I have 4x. How? 2 times this. Again, this times this, you have 2. Now come down and do the same thing. So you have 3x here, and then you have 3. Come here and quickly duplicate that. You have this, and then here you have 12x, and here you have 8. Now, I told you method number 1. The method number 1 is that I'm taking this, I'm taking it up. How do I do that? I'll simply say 3, 4x, 2. The base are the same. What do you do to the power? Because it's a division rule, I am going to minus here. So I have to do this so that you understand. This is it. The reason I'm putting minus is because this is going up. And so if it's going up, you have something like this. That's simple. You may want to ask, where is this coming from? Do not forget what I said. This raised to power A. This is the division. And that's what you're having here. The base are the same. You minus the power. Exactly. So we are minusing the power because the base are the same. The base are the same, and then you minus the power. So we have this. So 3, 12x, 8. And then I can easily just cancel so I don't waste my time. And then come up here, you have 4x, 2. You have 3a. I need to stand a note of 1 in here. There are students that we introduce minus, they will not put the brackets, and then the minus will not affect it won't affect it, you will miss it, you won't get it. So always put bracket so the minus can open it up. And so you have 12x here minus 8. Collect like things. There are things that we need to collect. So we have 4x here minus 3x here, and then 12 is plus, come here, it becomes minus, and then we have minus 8 here, this is coming here plus 2, this is coming here plus 3. Okay, so we have, what do we have here now? This is 4x minus 3x, that gives us x. Or we can say minus 3x minus 12x, that gives you minus 15. And for those who are having issue, maybe you are having issue with things like this, you are owing 3 naira, you haven't paid, you went to borrow again, and then here you are owing another 12 naira, and that gives you minus 15. The minus shows that you are owing, so you have something like this. The same thing applies here. This plus this, that's 5, minus 8 plus 5. You are owing 8 naira, and you have 5 naira in your pocket. You give out the 5 naira you have, and you are still owing minus 3 naira. And so here you have, look at it now, minus 11x, and here minus 3. Minus can cancel minus. And then the next thing is you're looking for x. So you divide both sides by 11. Divide both sides. That's the meaning of this. Divide both sides by 11. So that gives you this. Cancel this, cancel this. And automatically you have 3 over 11. I'm sure that's pretty simple. I like to solve one more question. This is a situation where you are given a particular question and it might not be as straightforward as it. Let me explain what I'm saying. Number 4. You are asked to solve something like this now. Solve 5 raised to power x plus 5 raised to power x plus 1 plus 25. This is not as direct as what we've been doing since. Because here you have x raised to power x, 5 raised to power x, and here you are having 5 raised to power x plus 1. And then, so how do I can even tell you the answer without solving. I can tell you what you will do here, and then you just arrive at the answer. So there are 2 ways to, I told you I was going to do two methods. Let me explain the second method. The second method without solving is that when you get to this place, or you may choose to get here, when you get here, simply cross multiply. That is, cross multiply. When you cross multiply, obviously it becomes what? Multiplication. And so if it's multiplication, the base are the same. What do you do to the power? You add the power. Remember, if it's multiplication, this will be addition. That is, if I change this to multiplication now, this becomes addition. And that's what we do right there. So we solve the last question here. To solve the last question, I'm looking at something like this. I could just say 5 raised to power x plus 5 raised to power x times 5 raised to power 1 equals to 25. So you can see that. You can see that. Let me change this to 30. Let me change the original question to 30. And so let me change this to 30. And now, so I'm having something similar, and this is addition. You should never, you wonder what I did here. It's the law of indices. The base are the same, you can add the power. So I will say, let 5 raised to power x be equals to what? P. Meaning anywhere I say 5 raised to power x, I will put P there. So you are plus P times 5 equals to 30. So that I will have P plus 5P equals to 30. And here this means 6P equals to 30. Okay, I'm sure this is clear enough. Now coming to do this here, so we have 6P equals to 30. Divide both sides by 6. Divide both sides by 6. So that gives us 5. Do not forget that we are not told to find P. We are explicitly told to find X. It is X that we're given at the beginning, and so you're not finished what you are told to solve. So what do we do? You will now say in the examination condition, but P equals to 5 raised to power x. So anywhere I say P, I put 5 raised to power x. So I have 5 raised to power x equals to 5. 5 raised to power x equals to 5 raised to power 1. 5 raised to power 1 is the same thing as 5. And this cancels this, and then my x is equals to 1. That's the final answer to the question. Now, before I close the class, now you want to check up if you are correct. Anywhere you see x1, you put it there. Put it here. For example, put 1 here. That's 5 raised to power 1. Put 1 here. 1 plus 1, that's 5 raised to power 2. That's 25. 25 plus 5, what would that give you? 30. Telling you that what you got is actually correct. You can always go back to check what you have solved and check up whether you are actually correct or not. I'm sure this is quite helpful. But in case you are still having any confusion or any area of clarification on any of our videos on our channel, you are free to always drop your concern, your question, or whatever you are having issues on. Always drop your question on our channel. I will be glad to attend to you. I'll be glad to answer your question, okay? If the video made sense to you, also share with your friend, like, and if you are yet to also subscribe on our channel, you do that now, and we'll be glad to impart you in every way we can. Thank you. Bye.